So we're continuing our work with normal distribution. So far we've learned the difference between uniform, which is a set of data that's all very similar, skewed, which means they are all very small or maybe all very large. The graph is kind of pushed either to the left or the right. And then we've got our normal curve, which is shaped like a bell shape. It's a normal distribution. Now, we talked about some memorized percentages. Those percentages, if something is normal, and we would have the mean right in the middle, and then we've got our bell-shaped curve, it looks something like this. And then if we go one standard deviation, so basically what happens is we're looking at our z-scores here. If the mean is has a z-score of 0, this would be 1, 2, and 3. This would be -1, -2, and -3. And then our memorized percentages, there'd be 68% in this range, so 34% on each side. And then we extend it to 95%, which is another 13.5 on each side. And then we extend it to 99, which is another 2%. And we have 0.5% on each side. Now, in using the standard normal table, and this table is going to be found in the FST textbook on page 664. I'm also going to include a copy of this in your Schoology folder for this day. You can use that table to find these. But how the table works is, let's say we have a score that is in this area right here. And let's say it has a z-score of 0.5. So on the table, you would go down the left-hand side to the positive 0, and you go over on the top to the 0.5, and if you go down to 0.5, you get a value of 0.6915. That means that there's 69.15% of data less than this value. Okay, the chart will always tell you what's less than. So if we wanted to know what's greater than, it'd be 1 minus that, or in this case, 3085. All right, if we're talking about a score that might be in this range, about right here, let's say it has a z-score of 2.2, then we would go down underneath the z column to a positive 2, go over to 2.2, and that would be a value of 0.9861. That means that about 98.61% would be to the left of that, and then 0.0139 or 1.4% would be to the right or greater than. The chart always telling you what's less than. All right, so a couple examples. Standard aptitude test. Scores are normally distributed. Right away when I know that, I'm going to make my normal curve. It says it has a mean of 100. I'm going to put 100 right in the middle. And a standard deviation of 10, which means if I go 110, 120, 130, I have those memorized percentages. And I could put those percentages in 34, 34, 13.5, 2, and so on. So now let's just find the percent of scores that are less than 95. So 95 would be right here. Okay, I would convert that. I'm going to standardize that score. So remember, I take the score minus the mean. I divide by the standard deviation. So that's a -5/10, or that's a -0.5. I'm going to look that up on the chart, go down to -0 in the Z column, over to 0.5, and I get 0.3085. That is the percent that would score less than 95. That would be about 30.85%. Okay, greater than 115. So 115 I know is going to be about right here. Converting that, it'd be 115 minus the mean, which is 100 divided by 10. That's 15 divided by 10, which is 1.5. That's the Z score. So I look up 1.5 on the chart, go down to 1, over to 0.5, and that's 0.9332. That would be what's less than that. So what's greater than that would be 1 minus that, which ends up being about 0.0668, which would be about 6.68%. Okay, between 90 and 110. For this problem, 90 is right here, 110 is right here. This is one that should be just memorized. We wouldn't have to use the chart at all. It's those two percentages. It's within one standard deviation, which would be 68%. Here's another example. In a very large factory, employees must report to work at 8 a.m. The arrival times of the employees are distributed with mean of 7:52 a.m. and a standard deviation of 4 minutes. So on this one, my normal curve is going to look like this. My mean is 7:52. I have a standard deviation of 4 minutes, so I'd have 7:56, 8 o'clock. Over here I'd have 7:48, 7:44. And again, those memorized percentages would fall into place. And now, how many employees would be late? So to be late, you would be coming in after 8 a.m. Here's 8 a.m. What's later than that would be the 2% and then the 0.5%. So I could say that this would be 2.5%. All right, arriving between 7:59 and 8 a.m. So 7:59 and 8 a.m. Here's 7:59, which would be about right here. And 8 a.m. is right here. So 7:59 would be, if I go and standardize that score, 7:59 minus 7:52 is 7. Divided by 4 would be 1.75. That's the Z-score for that value right here. And then 8 a.m. is 2 standard deviations above the mean. That would have a Z-score of 2. Okay, using the chart, I could look up 2.0 on the chart. That's 0.9772. That would be the percent that's less than 2, the 0.9772. Okay, 1.75, and we're going to make this easy, round to the nearest tenth. I'm going to think of this as 1.8. If I look up 1.80 on the chart, that's 0.9641. And I'm going to subtract these because I want to know what's in between them. So subtracting that would give me 0.0131, or about 1.3% would have scored, or would have arrived between 7:59 and 8 a.m. that day. The last one here, to arrive before 7:45 a.m. 7:45 would be right here. So you can kind of get an idea of how many would be before that. But to convert this, again, 7:45 minus 7:52 is a negative 7 minutes. I would divide that by 4, that's a negative 1.75, which I would round to negative 1.8. If I look that up on the chart, negative 1.8 is 0.0359, which means about 3.6% would arrive before 7:45 a.m. I hope that helps you with some of the problems that you'll be asked to do. Some of these you need to use the chart for if it doesn't come out to be one of those memorized percents. If it's a memorized percentage, just go ahead and use those.